In this video, I will explain Opamp voltage series feedback amplifier concepts. Opamp voltage series feedback amplifier. It is also called as a non-inverting amplifier with feedback. Non-inverting operational amplifier Opamp with feedback. Here, first of all, you have to draw the circuit diagram related to this one. See the Opamp with gain is open loop, gain is A. This one is non-inverting terminal plus, inverting terminal is minus. This one is Vin. Vin is applied to the non-inverting terminal of the Opamp. This one is some resistance. Voltage divider bias resistance circuit is applied here. This one is R1. This one is output V0. This one is feedback resistance R. Feedback resistance R. This one is V1 and V2. Another way of draw this circuit diagram is Opamp with gain is open loop gain is A, output is V0. This one is minus, this one is plus. Vin is applied here. Vin is applied here. Here voltage is V1. And the resistance here R1 is applied here. Some ground. This one is R. Both the circuits are same. Both the circuits are same. This is the feedback network. This is the feedback network. Consists of RF and R1. Feedback means a fraction of output is connected to inverting terminal of the Opamp, that is at V2, through R1 and RF. This is the feedback network. This one is feedback network. Feedback network. First, find out the gain of the feedback circuit. The gain of the feedback circuit. The gain of the feedback circuit is B. Circuit is B. This one is the voltage across R1 is Vf. This one is V0. B is equal to ratio of output voltage by input voltage. Input to the feedback network is V0. Output of the feedback network is Vf. The ratio of output voltage by input voltage. Output voltage is Vf. Input voltage is V0. Therefore, Vf is equal to B into V0. Vf is equal to B into V0. Find out Vf voltage. According to voltage division rule, Vf is equal to total voltage applied to this feedback circuit is V0. V0 into this resistance R1 by R1 plus R. From this, Vf by V0 is equal to R1 by R1 plus R1 plus. So this one is RF, not RF. R1 by R1 plus RF. This is called as B. Therefore, finally, B is equal to feedback factor. Gain of the feedback network B is equal to R1 by R1 plus RF. This is the first point. Next, second one is the closed loop gain is the closed loop voltage gain. Voltage gain is the closed loop voltage gain is output voltage by input voltage. Output voltage here is V naught, input voltage is Vn. Therefore, AB is equal to closed loop voltage gain, that is AB is equal to V naught by Vi. 1 plus Rf by R1 into some important point here is 1 minus 1 by A. This A is called as open loop gain of the op amp without feedback. 1 plus Rf by R1. This is the gain error. This one is gain error. We know that voltage gain, closed loop voltage gain of the op amp is represented by AV, that sometimes it is also called as AF. AF is equal to output voltage by input voltage is equal to 1 plus Rf by R1 into 1 minus 1 by A into 1 plus Rf by R1, gain error. Another formula for this gain is in the same, or AF is equal to V naught by Vi is equal to open loop gain into R1 plus Rf by R1 plus Rf plus A into R1, A into R1. A, where A is called as open loop gain of the op amp. Open loop gain. Open loop gain of the op amp. Open loop gain, ideally it is infinity. Therefore, A into R1 is far greater than this one, R1 plus R. Therefore, simplify this expression. A into R1 plus Rf by, neglect this term, A R1. A is cancelled. Therefore, R1 by R1 is 1 plus Rf by R1. This one is exact voltage gain, closed loop voltage gain of the op amp. This one exact. This one is ideal. This formula is also exact. This formula is also exact one. So many formulas are there for closed loop gain of the amplifier op amp. I will show here. Next one is another R. AF is equal to output voltage by input voltage, A into R1 plus Rf by R1 plus Rf plus A into R1. Common term is here, A into R1 plus Rf by R1 plus Rf is the common term. 1 plus A into R1 by R1 plus Rf. R1 plus Rf and R1 plus Rf is cancelled. Therefore, AF is equal to closed loop gain of that non-inverting operational amplifier. A by 1 plus A into R1 by R1 plus Rf. We know that R1 by R1 plus Rf is B. R1 by R1 plus Rf is B. Therefore, AF is equal to A by 1 plus A B. These are the three important formulas related to this one. 1, 2, 3, here 4. 4 important formulas related to closed loop gain of the operational amplifier. in non-inverting mode. Non-inverting mode means Vin is applied to plus terminal, that is called as non-inverting terminal of the op-amp. Non-inverting terminal of the op-amp. Where AF is called as closed loop voltage gain. Closed loop voltage gain. Closed loop voltage gain. Here A is called as open loop voltage gain. Voltage gain of the op-amp in non-inverting mode. Closed loop voltage gain decreased by a factor 1/1 plus A beta. This A is called as gain of the operational amplifier without feedback. AF is called as gain of the operational amplifier with feedback. Next important parameter is input resistance. That is input resistance with feedback. With feedback for voltage series feedback connection or non-inverting amplifier operational amplifier mode. With feedback, RIF is equal to RI into 1 plus A into B. This is the input resistance of the op-amp with feedback is 1 plus AB times that of input resistance without feedback. In the circuit, Ri is the input resistance of the op-amp without feedback. That is called as in the op-amp is a open loop condition. Input resistance with feedback increased by a factor 1 plus AB. Next one is output resistance. Next one is output resistance. Output resistance of the op-amp with feedback. Is ROF is equal to R0 by 1 plus A B, where R0 is called as output resistance of the op-amp without feedback. ROF is called as output resistance of the op-amp with feedback. Similarly, here RI is the input resistance of the op-amp without feedback. RIF is the input resistance of the op-amp with feedback. One more important is here frequency response characteristics. Bandwidth with feedback. Bandwidth with feedback. Bandwidth with feedback. That generally consider gain versus frequency curve of the op-amp. This one is gain is along the y-axis and the frequency is along x-axis. For 741 IC, this is the gain. This one is gain of the op-amp along the y-axis. For 741 IC, the gain is 2 into 10 power 5. The gain is 2 into 10 power 5. Here, some the characteristic curve is like that. This one is called as F0. This one is called as F0. F0 is 5H. F0 is 5H. For high gain, the bandwidth of the op-amp is very low. That is 5H. Therefore, this is called as a crossover frequency. This is called as a crossover frequency. Therefore, this frequency is not considered. For higher bandwidth, you need to consider unity gain bandwidth product. Unity gain bandwidth product. That is here unity gain bandwidth is equal to 2 into this one is called as open loop gain of the op amp. Very high value, 2 into 10 power 5. 2 into 10 power 5 into 5 H. This is 5H. That is 10 into 10 power 5 H. That is equal to 1 megahertz. At 1 megahertz frequency, here at 1 megahertz frequency, 1 megahertz frequency, the gain of the op amp is unity. The gain of the op amp is unity. The bandwidth is approximately equal to 1 megahertz when gain is 1. When gain is 1. The gain bandwidth product is constant 1. The gain bandwidth product is constant is equal to unity. The gain bandwidth product is constant. The gain bandwidth product is constant. Constant is equal to unity. Is equal to unity. Here some open loop gain. This one is open loop gain. The gain of the op amp is unity at 1 megahertz frequency. In middle some another parameter is there that is called as bandwidth with feedback. Bandwidth with feedback. Generally, the relation between the feedback frequency and the open loop voltage gain. Here, the relationship between the break frequency, F naught open loop voltage gain, A bandwidth with feedback. Bandwidth of the op amp with feedback is F, and closed loop gain is A, and closed loop gain is AF. We know that unity gain bandwidth under open loop condition is equal to break power frequency F naught into A. A is the open loop gain of the op amp. Similar in the fashion, unity gain bandwidth product for feedback is frequency is FF, the voltage gain is AF. This one is 1, this one is 2, both are equal. Therefore, F naught A is equal to FF AF, for F suffix capital F is equal to F naught A by AF. F naught A by AF. F naught AF is equal to, we know that 4 AF formulas are there. We use one AF formula, A by 1 plus A, B, A cancel. Therefore, F naught into 1 plus A, B. Where B is called as a feedback factor. A is called as the open loop gain of the op amp. F naught is called as the corner frequency or break power frequency of the op amp. The bandwidth of the non-inverting amplifier with feedback, that is FF, is equal to its bandwidth without feedback, F naught, times 1 plus A beta. The closed loop bandwidth FF can also be determined from the open loop gain versus frequency plot. This is the open loop gain. This is the open loop gain versus frequency plot. From this also I have to calculate closed loop bandwidth, that is FF. We locate the closed loop voltage gain value on the gain axis. Locate the some value on the gain axis and draw a line to this value parallel to the frequency axis. Parallel to the frequency axis. Then we project the point of intersection of the line with the curve. Some intersection is there. Project the line, point of intersection of the line with the curve on the frequency axis. This is the frequency axis. And read the value of the closed loop bandwidth. This one is like this 1 megahertz is called as unity gain bandwidth. At this one, the gain of the op-amp is unity. If you want to calculate EF value from this characteristic curve, frequency versus open loop gain characteristic curve, you have to locate AF on the y-axis, gain axis, and draw the line. By using that point, draw the line parallel to that frequency axis and meet at a point, intersection point on the curve. Project this point towards the x-axis, meet at a particular point that is called as FF. This is the closed loop bandwidth. FF is called as closed loop bandwidth. One more, last one is characteristic of that non-inverting op-amp is total output offset voltage, total output offset voltage with feedback. Generally, output offset voltage is undesirable one. It disturbs the operation of the operational amplifier. Need to eliminate this output offset voltage. The output offset voltage is due to either input offset voltage or input offset current, base currents, like that. Bias currents, like that. In order to eliminate this one, by using that feedback, therefore, total output offset voltage V over T is equal to plus or minus E saturation value by 1 plus A T. Non-inverting amplifier with feedback exhibit its the characteristics of the perfect voltage amplifier. Non-inverting amplifier, operational amplifier with feedback exhibits its the characteristics of the perfect voltage amplifier. Important bit. Perfect voltage amplifier characteristics. The characteristics of the non-inverting operational amplifier is same as the characteristics of the voltage amplifier. That means very high input resistance, that is RIF is equal to RI into 1 plus AB. Very low output resistance, ROF is equal to capital F for our representation, R naught by 1 plus AB. Stable voltage gain, that it means AF is equal to V naught by VA is equal to A by 1 plus AB, and increase the bandwidth. Increase the bandwidth, that means FF is equal to F naught into 1 plus AB, and decrease the total output offset voltage. Total output offset voltage VOT is equal to plus or minus V sat by 1 plus AB. These are the some important formulas related to voltage series, op-amp voltage series feedback network or non-inverting operational amplifier with feedback. Feedback